Hello everyone, welcome to this presentation where I will be introducing you to cryptography. So let's get started. First things first, what is cryptography? We know that whenever you want to send a message or a letter to someone, there are computers or people involved, like in between you and the sender and the receiver. It can be a postman or multiple internet servers across which your data needs to travel before the receiver can receive the message. So basically, almost everything which happens today on the internet involves data transfer, and so we obviously would not want anyone in the middle to get to know about such sensitive data. This is exactly where cryptography steps in. It is basically the method we use to protect the information by using a certain algorithm to make it meaningless or unreadable text, which can later be decrypted back to the original text by the receiver. So the prefix crypt in cryptography means hidden, and graphy means writing. Going ahead, coming to the basic terminology. Plain text. Plain text is the message one wants to send or the data. Ciphertext. It is the meaningless or unreadable output of an encryption algorithm. Encryption. The process of encoding information, basically turning plain text into ciphertext. And decryption. This is the process of getting the original plain text back from a ciphertext. And this is usually done with a key. Going ahead, I will give you a few examples of ciphers or cryptography systems. First one, symmetric ciphers, which include two more subdivisions, which are stream ciphers and block ciphers. The second one being asymmetric ciphers, and the third one being hash functions. So in symmetric ciphers, both encryption and decryption can be done using the same key. In asymmetric ciphers, we will be using a public key and a private key to do encryption and decryption. And hash functions are a kind of one-way cryptography systems where there is no way of getting back the original message from a given ciphertext. Going ahead, I will explain you XOR cipher. This is an example of a stream cipher which basically does the XOR function on each and every character between the ciphertext and a given key. Merely reapplying XOR on the ciphertext will give our plain text back. So let me explain how the XOR function works. So the XOR function takes two inputs and gives back one output. So let us assume A and B to be inputs here. So when the XOR function takes in 0 and 0, we get a 0. 0, 1 gives 1, 1, 0 gives 1, and 1, 1 gives 0. So you can remember that whenever both the inputs are equal, we get a 0, and when they are different, we get a 1. And XOR can be very secure if it is used properly. Going ahead, there are different types of XOR ciphers. One is a one-time pad, the second one is single byte XOR, and third one is repeated key XOR. Coming to one-time pad, this is basically nothing but XORing a plain text with a key of same size. So how many ever characters the plain text has, this key will have the same number of characters. So how the encryption works here is, firstly we will XOR the first character of our message and the first character of the key, and the result of this XOR function, it will be the first character of a ciphertext. So doing this repeatedly for every given character, we can get a ciphertext which is equally long as these both tricks here. So we are supposed to XOR the uppercase T with lowercase t here. So first we will write their ASCII number in binary, both of theirs. So applying bitwise XOR on this both bytes, we get another byte, which will later be, and the same thing will be repeatedly done for every character of this plain text and key. So going deeper into one-time pad, we will realize that this is not at all an ideal method, because however big the plain text is, it requires the key to be equally bigger. Let me give you guys a live example of doing this in Python. So let me start. There exists a predefined module called PwnTools, which has a XOR function, which I will be using now to explain you how this will go on. So let us assume a plain text here. So pt equals this is message. So I made it so that this is 16 bytes long. And let us also assume a key which is 16 bytes long. A popular one used is yellow submarine. Yellow submarine. Okay, so let us encrypt the plain text using the given key. So XOR of plain text comma key gives us this. So this being the message using this key, and so this being the message and using the XOR cipher on this plain text, we made the message meaningless. So no one can understand the message from this ciphertext. And when the receiver receives this message, and when he knows that we XORed it with this key, he can XOR it back by doing XOR of the message comma the key, which will give us back the original message. And therefore anyone in the middle will only know about this message and will completely be clueless of what the message is. So we should realize that this is not an ideal method. Okay, so if we have 1 terabyte of data and we want to encrypt it using one-time pad, we will require 1 terabyte of key, and that is not at all an ideal scenario to store 1 terabyte of a key. Therefore, people generally use the other two methods given here, single byte XOR and repeated key XOR. And going into their explanation as well. So it is basically similar, but what happens here is the key does not require to be as big as the message is. In single byte XOR, we only require 1 byte of a key. So let's use the same plain text as before. And let's change the key as just a letter K. Let's multiply this 16 times. So whenever we call key, we get 16 Ks. So basically what we do is we XOR every character of the plain text with just a single byte. So the XOR goes like this, pt comma key. It will give us this, which still works great, but we should know that there's a vulnerability here. As we are only using 1 byte which is repeated 16 times, people might guess what this byte is, because there are limited number of options what 1 byte might possibly be. So even single keys are is not secure enough. Then going to multi-key, we're going to repeated keys, or for the key we can use a small word, for example aloha, and we can keep on repeating it till we reach 16 characters in the key. So So basically they're just repeating one small word many times till it matches the size of the given message. So let's see what happens when we sort this plain text with the given key. So our pt comma key gives us this. So we get another ciphertext which is completely meaningless. And this is more secure than single byte XOR. These are the three XOR cipher that I just explained, and thank you for watching. And if you're really interested in cryptography, we recommend you to learn Python, and you can also visit us on our wiki page where we cover more topics in detail. Thank you.